Okay, so for the next probably week or so, this section 1.2 we will be going through. Today is just tell whether a relation is a function, use function notation, and find domain and range. What we will be doing really in the section, why it takes so long, is we're going to look at all these things about functions. So domain and range we talked about last year. Continuity, no. Increasing and decreasing, we talked a little bit about, not much. Boundedness, extrema. If I tell you extrema are maxes and mins, we did do a little. Symmetry, no. We did talk about asymptotes. We did talk about end behavior, but how we're looking at this is with mathematical functions. And you're going to see in the next section there are 12 basic functions. We looked at 10 of them in Algebra 2. So 2 of them we just didn't do. So to start, functions and their properties. A function from a set D to a set R is a rule that assigns to every element in D a unique element in R. Really, this unique element in R, what is that we should remember? X can't repeat. So for any X, there's only one Y. Now, there could be the same Y going to 2 different X's. Input, our input is our X or our domain. Output is our range or our Y. To think of this idea, if I went down, we know function notation, Y equals f of x. So f of x is your function, x is what you put in, y is what comes out. Mapping, if I said which one of these is a function, hopefully if you look at that, this is yes, this is no. This is okay. Okay. This can't happen. You cannot have 2 x's going to the same y. Now, if we talk about the graph, a graph of a function, if you graph something, you put in x, you get a y, which is f of x, and then you get a bunch of ordered pairs, and you graph them. So you get these points by putting in x's, getting y's, and then you graph them. The big thing with the graph that we talked about, vertical line test, you can't have 2 x's repeat. This is a function. This is a function. This is not a function. I can't have this one x give me 3 different y's. So that idea should be pretty, we got that. Now, finding domain and range graphically. This is what we don't do in this class. This is what we did in Algebra 2. So at the very beginning of the year, this is where we used to say, so domain, left to right. This domain last year, you would have written, not an 8, you would have written negative infinity, less than x, less than infinity. What are we writing that is? All your x's are used. Your range, what you think low to high. Your lowest y was 0 to infinity. So that was our domain and range. writing with interval notation. Domain here, all left x's, all right x's. But then range, low to high, it goes down to negative infinity, but it stops at 1. So that's getting used to sort of writing those. Now this one, left to right, it stops. What's the leftist most x? Negative 3, and it's a closed dot. What's the rightest most x? Positive 3. Low to high, what's your lowest y? What's your highest y? 4, 5, 6, 7, maybe 8. So that gives you an idea of remembering that. Now, what do you do when you have like an asymptote? Well, if you think left to right, negative infinity, though it's going to the left, but it stops at 0 and it doesn't touch 0. Then it starts again at 0 and goes to the right. Range, lowest y is negative infinity. Doesn't touch 0, but then right above 0, and it has an arrow pointing up. So what that's giving you an idea of is how to write these things with interval notation. Now the problem is you're going to be doing these algebraically without a picture. So with this one, domain, you think left to right, just to give you an idea, that would be an arrow. That would be an arrow. You just don't see those. It is going to the left, but it stops at negative 1 because there's an open circle. Then it starts again right after negative 1 until it gets to 3 because there's an asymptote. And then after 3, it starts again and it goes to the right forever and ever. Same thing with your range. It's got an arrow pointing down, but then it's got an open dot at 0.75. Then after 0.75, it has an asymptote at 1. And then after 1, it keeps going up forever and ever. So those are some strange things with a picture. Now we have to think we got to get those with our head. So for the pre-intro ideas, we are doing these with algebra. So I'm not going to look at this picture. I'm going to look at this and I'm going to say, what's the domain? Well, what we have to think of is, where do these functions not work out? Well, there were two big ideas in math that came across last year. And if I sort of write these down first, the two big things you cannot mathematically do. First one, can't divide by 0. I mean, that was big last year. Second one, you can't actually even root, but we really just look at square root. You can't even root a negative, because if you do that, you get imaginary numbers. We're talking about real numbers. Now, what's the third thing in math you can't do? Can't take the log of a negative, but that's not going to be something we're going to be talking about right now. So if I said, well, what can x not be here? X cannot equal 3. Well, so then when you think about domain, what is domain? What can you put in? Anything except for 3 would actually be that. You look at the second thing. You cannot square root a negative. So you have to think, well, if it's not negative, that has to be greater than or equal to 0. So that would mean x is greater than or equal to 3. So what's its domain? I can put 3 in and anything after 3. Well, if you look at this last one, this has to be greater than or equal to 0. This has to be greater than 0 because it can't be equal to 0 because it's in the bottom. So this is x is greater than 3. This is x is greater than or equal to -1. But if I think of putting that together, and what a lot of people last year, they like to think of domain like think of a number line. Greater than or equal to -1 is all those numbers. Greater than 3 is all those numbers. You have to put in the intersection because the fact that 0 would work on the top, it doesn't work on the bottom. And I put 0 in the top and the bottom. So if I ask you for the domain of that, you're actually going to have 3 to infinity. And we're doing all this with our head. We are not doing anything with a picture. And don't get used to cheating because it won't help you. So the thing that we want to remember, and this is on the little note page, domain is what we can put in. Okay? Range is what comes out. So when we think about this and we want to find the domain, first thing you want to remember, polynomials, their domain is always everything. Now, big question, what's a polynomial? Polynomial is x squared, x cubed, x to the first, x to the fifth, x to the 99th. No negative exponents, no fraction exponents. If you have a polynomial, its domain is -infinity to infinity. If you have square root functions, what you want to do is think, set what is inside greater than or equal to 0 if it's on top. If it's on the bottom, you would want to set it greater than 0. So that's the first thing. That's the second thing. Third thing, if you have a fraction, which is rational functions, if you don't remember that, fractions. What you want to remember, the denominator cannot equal 0. So you find that, and that's the exclusion from the domain. So a couple quick just sort of examples, and then I'll be done for today. So I'm not using a calculator. I'm not looking at the picture. Find the domain. Well, I need to think. Out of those 3 things, what is that? That is a polynomial. So when I see a polynomial, my domain is automatically -infinity to infinity. Think about it. You can put in anything you want. There is no problem with any x that you put into that function. So, second one, I'm not thinking what that picture is. I'm just thinking, hey, that's got a square root. I cannot square root a negative. So what that means is that what's underneath has to be greater than or equal to 0. Solve that, and be careful when you solve that, because if you divide by a -3, that switches the inequality. So what's that saying to you? I can put in any x less than or equal to 2/3. Now, again, like I said, some people like to think, okay, what's that mean? That's what I can put in. In interval notation, what is that? You can put in anything from negative infinity to 2/3 and try it. Like, what if you put 4 in? If you put 4 in, you'd have 2 minus 12. You can't square root negative 10. So you can try things. Last one, you have a fraction. You don't have a radical. Now, eventually, you're going to see fractions and radicals. So what do I have to think of? I cannot divide by 0. Well, now I have to solve that. That's a quadratic. Square root, factor, quadratic formula, whatever. This one, square root, I could just use square roots. X, what can I put in? X cannot be 2 or negative 2, which really means I can put in anything except those numbers. How do you interval notation think of that? Left to right, I can put in things from negative infinity to negative 2. I can't put in negative 2, but then I can put in anything from negative 2 to 2, but I can't put in 2, and then I can put in anything after 2. So that is a quick, I mean not quick because it's like 17 minutes, but that gives you an introduction of domain. With range, which you might have a couple, think of range graphically right now. Look for all y coordinates low to high. Because we're writing as intervals, smallest number goes before the biggest number. So you're going to have a couple of those to try. All right, we'll see you tomorrow.